Hello, this is Tilin Günger. I'm going to talk about mobile quality. The topics I'm going to cover is talking about the mobile devices, challenges in mobile, and test automation and mobile test automation approach. Of course, mobile quality is a very wide area that we can talk about too many things. But in the slides on my project, I focus on one specific part of it, which is the mobile application testing. Um, let's take a look at the challenges in the mobile first. There are a lot of devices out there, physical devices that like iOS, Android, the Blackberries, Windows phones, and Nexus. There are a lot of devices, so you need to make sure that your application is working on the devices that you want to work to. For example, what could be the problem? For the screen sizes, it's very important, or the actions that you to vertical or horizontal that you need to test with. So your this condition, it enhances your test cases because you need to cover all of the you want to cover the devices, more than one. You're not going to for example, if you have if you're a banking application and you cannot even miss any one transaction because it's really important for you. So, and for the vertical view, when you're rotating your phone, if you lose it, it could be a very big problem. And for this is operating systems. This is one of the other challenges in mobile. Of course, this is not unique for mobile devices, but what is unique? What is the unique thing about is that, for example, you're testing for Android, but there are a lot of Android devices, especially. And for Android, there are a lot of Android operating system versions out there, like Marshmallow, KitKat, Ice Cream Sandwich. You want to make sure that you support that specific versions, and you need to make sure that the versions that you support, your application is working on them. And for iOS as well, there are a lot of operating systems. And respect to operating systems, your application may behave differently. What I'm saying here, and there's an example that we can see, and the first picture is an Android application, and the second one is an iOS application. And what I want to show here is that, and you're just clicking one button in the Android application and you're passing the other screen. This is a e-commerce application, for example, and you want to select the date. And for iOS one, you need to select the date and you need to click the done button afterwards. So they're like Android and iOS. This is a hybrid mobile application, but because they are using native components of the mobile devices, then they may differ. They may behave differently. The other challenges in mobile, one of the unique challenges is network connectivity. You want to make sure that your application is working for the different network types. In daily life and with the mobile devices, you're using everywhere. Usually the case when you're walking on the streets that you can lose your connection. For example, you can when the users are using your application, the network connectivity can be changed. For example, when people go to metro and they lost the connection, you want to make sure that your application is working on an offline mode, for example, and or it's adding in a queue your transactions, and after it catches the connectivity, and they're going to execute it. So this is one of the other unique challenges in mobile testing, and there too many. What I'm indicating here, there are too many things too many conditions to test. Then your graph increases linearly when you add those conditions, different network connectivities, different operating systems. All different operating systems has a different browser types, and also behind additional to that, to those challenges, and mobile world is very quick. You need to be very you need to develop your application very fastly. So the release schedule are so tight. So you want to develop your application very quick, and you want to test your application very quick. But all of these challenges, it is not possible to test it every condition. That the first thing that you need to make sure which you need to check your business analytics, and what are the most used browsers, what are the most used devices, what are the popular operating systems that I need to test with, or what are the most used network connectivities. Once when you define those, your test environment, it's going to be a lot still, but you're going to reduce the number of the test cases by defining your test environment in the breakdowns. Then you can decide to how are you going to support the quality. Then what is quality? Quality is reasonably bug or defect free, and your software should meet with the requirements and the expectations, and also you should deliver your application within the budget, and it also should be maintainable. And how can we support the quality? And we can write a test automation. Why test automation? Because test automation decreases the number of the human errors, and it supports reusability, because you can run the same test again and again, and simultaneity. You can run your test as a parallel, and there are a lot of open source frameworks out there that you can use, or paid ones, of course. And running tests whenever. I think this is one of the most important thing, that because your manual tester probably cannot run the test in the night, and probably cannot run the same amount of tests what the automation do. This is the running test whenever. This is for example, you have a continuous integration testing lifecycle system, and you want to make sure when you go to work, you want to make sure that your tests are executed nightly in the night, and you receive the test results in the morning. So in every morning you can see your okay, and my application is working, or my application is not working. So it's not possible with the manual testing. This is why test automation is important. Then return of investment. I want to talk about the return investment of the test automation, and there's a graph for it. Let's take a deeper look to that graph. This is saying it's, as you can see here, and the manual testing and automating testing start at 0 point, but the automated testing is higher than manual testing. Why? Because it requires more developed test framework, designing, like taking decisions, and skilled test engineers. That's why it's higher than manual testing at the beginning. But at the end, not at the end, after a while, you see that the line is stable. Why? Because why it's not going down? Because it's a maintenance cost. This is maintenance cost. And for the manual testing, it increases linearly because this is cost is increasing linearly by the time because you're adding new features to your application, and at the end you cannot test. Your tester needs to spend more time on it to test manually, and you are going to hire new test engineers for it. And how can we decide the test automation? And there's a formula for calculating the testing costs. Manual preparation cost here, and manual testing cost and automated testing cost. Let's say manual preparation cost is 1. And we are going to execute that test 10 times. And let's say manual execution cost is 10. Because it's going to take time, you need a human for it, then with 10 multiplied by 10 and plus 1, this is 101. Automatic testing cost, let's say automatic preparation cost is 10. What was it? This one was 1, this is 10. And we are going to execute it 10 times, but automatic execution cost, okay, it is not that cheap because you need to maybe add some cloud systems, some working environment, but it is not that manual execution cost because it doesn't require a person for it. So 5. Then 5 multiplied by 10, and this is 50, and we said this is 10, and this is 60. As you can see here, this is 101, this is 60. What I want to show here, it is manual execution testing cost is much higher than automation. So how can we decide it? And if it's whenever possible and if it costs little, you have to do it. And if it's like regularly and it costs, you still need to do it. But if it costs much, maybe your manager needs to take that decision. And yes, and one of the approaches that I'm going to introduce in this project is keyword-driven testing. Keyword-driven testing is a testing approach that uses data to contain the keywords related to the application being tested. And those keywords defines the actions that you can execute those test cases using that actions. Defining keywords, and it's really easy to understand, human readable because it's just the keywords that your test cases are keywords it's like a test documentation with a test automation code, and it's easy to use, easy to debug, and it's maintainable. I'm going to talk about deeply now for that. Here we are seeing an example keyword driven testing, an example test case used by keyword driven testing. Here there's like three lines. This is one test case. Open application DPU. DPU is one of the applications that I wrote. This is a variable that we are giving here. Open application DPU. Open this application. You can change the variable. Login and username and password. You can change that username and password later. And logout. The end user, what is important thing here, the end user is going to just call that keywords, those are the keywords, login, logout. If, for example, if your application's login page is changed, you added a CAPTCHA for it. You need to log in and fill the CAPTCHA. But you don't, this is a higher level keywords. Then you don't need to write here. You're going to into that login method, then you're writing inside of it like a login and CAPTCHA, and end users still don't see this. As you can see here, non-technical people, even they know the workflow, they can just write the test cases. This is why I am saying when I'm saying higher level keywords. We said that higher level keywords are here. Those are the login. Let's see how can we introduce in the mobile test automation framework. Mobile test automation framework is as I already talked about, there are a lot of devices out there that you can implement using, and also there are a lot of third-party libraries that you need to create your object repository, and this is I call it here object library. And your object repository should include all the it should include interactions between your with the devices, testing devices, and with your application. All this stuff should be handled in the lower level of the test framework. Then we said lower level keywords, like I said before, like login and captcha here, but higher level is a login, like a login before the lower level. Higher level is one step after. Then you can create your test suites and test cases here that customers or product owners even they can write the test cases for using those keyword-driven testing. And this is a nice meme that I wanted to show. It's the night before a bug bash, and the bug sees a nightmare. The testers have found the bug. Yes. The second approach that I want to talk about is data-driven testing. Data-driven testing is a testing methodology in which the same sequence of the steps are performed repeatedly using a data source of the dry input values. And you define input values and the assertions, assertions in your external data source. Then you directly call that external data source into your test, and you can repeat the same test again and again. And it prevents the hard coding, and it supports the reusability and modularity. Yes, what are the steps that if we want to use a data-driven testing? Firstly, and we need to create our test data. Test data, like I said, you need to structure test data. You have your test data, and you need to structure your test data by for example, by data by variable, or your inputs, what you're expecting output, because every test, when you do data, you change the data, and you need to assert your test every time to being able to test. And and implementation. This is an example data table here, and we can see this is the branch name and branch code. Those are my variables that we are going to see in my next slides, and those are the variables that I'm going to use, and my branch, and my branch 2, my branch 3, those are the codes. Those are the data. This is data tables. Yes, this is the example code that I wanted to show you while I'm saying hard coding, what I mentioned, which is this. For example, here, login. I said I just write a string here, admin as a login, but it is hard coded now. But to prevent hard coding here, I have a create new branch method that takes a two variable, and which are coming from that branch data CSV file. Like I said, we can use a CSV file or external Excel file, or something like text file that I'm going to call. And like here, as you can see, there are 3 different lines, and which means that this test is going to run 3 times with the different data, using different data. So which is really effective for time, for reducing the code number of code. So keyword-driven testing and data-driven testing is very useful, and increases the efficiency of the application of the testing project. So I think yeah, those are the good approaches that we can use it for, especially to beat with the mobile challenges. So thank you for listening to me, and that was my project. Bye bye.